I welcome you all to the Spark Research YouTube channel. This is Dr. Vishan, Assistant Professor in the Department of ECE. We are currently running in this series GATE 2025, right? So this is second part for this particular course, Electronic Devices. So we are going to take some more questions from this particular course, Electronics Devices, which has already been asked in GATE 2025, right? So here is the overview. This is another core course in this particular ECE, and you know that if you know the concept, then it will be very easy for you to solve the question and score the marks maybe in the range of the 10. What are the major topics? So, in this session, primarily we are going to focus on the carrier transport, right? So, the questions which is related to your diffusion and the drift and how your current will takes place in the your electronics devices. So, we are going to take, right? Okay, so let's take the question. So here is a question. Question is the electron mobility mu of n is a non-degenerate germanium semiconductor at 300 Kelvin is 0.38 meter square per. So what is given here? Given is your electron mobility, right? So what is the mobility? Mobility will give you the idea that how electron is flowing or moving inside the semiconductor. So in this case, inside the germanium semiconductor at this particular temperature, right? So your electron is moving with this 0.38 meter square per volt second, right? And then the electron diffusion, that is Dn at 300 Kelvin is how much will it? So this has been asked here. So as per answer key, your answer should be B, that is 98. So how can we find out? So actually, if you will see here, so here you have to find out the D, that is the diffusion constant, and you can find out diffusion constant using the Einstein relation, that is Dn is equal to mu of n and kt by q, right? So mu is the mobility, and k is your voltage main constant, T is your temperature, and Q is the electronic charges. So all the parameters has already been given in the right side, and only you have to find the T. So let's see exactly how to find out in more detail. And just for your information, like once you will get the value of diffusion, then how can you find the diffusion current? Diffuse after getting the diffusion constant. So current you can find like J is equal to Q D, that is dN by dx. What is this dN by dx? So this is your concentration gradient only, right? So this is a technique to find out the current density for the due to the diffusion. Okay, so let's see what is the diffusion exactly. It means, suppose this is a germanium semiconductor, right? So what will happen, since more number of electrons are in this side, and in this side suppose the concentration of your doped, you may have highly doped in this region, n type of doping, like suppose here more number of n types of doping, and here like intrinsic material, right, intrinsic germanium almost, and this here you have already doped the phosphorus. So what will happen, since more number of free electrons are here, so due to the concentration gradient differences, electron will start to move from higher density to lower dense. So that is why the once electron will start to flow, then automatically your current will start to flow in the reverse direction. So that is why how can we find out the flow of the current? So the flow of current will depends on the diffusion constant, that is D of n. So then how will calculate the diffusion constant using this Einstein relation, that is mu kt by q. So mu is your mobility, and kt by q is nothing. This is a fixed, that is the constant voltage, that is 25 millivolt, right, at the particular temperature 300 Kelvin. Okay, you may remember. Now let's see how to find. So mobility is given in your question, that is 0.38, and q you can use this formula, that is mu and kt, and q everything is given here. So you can use the formula to find instant relation to find out the diffusion constant. Once you will put, you will get the value of the dn, right? So diffusion constant, so you will get the value almost 98. So here we are going to see the question in and solution in some more detail, so that if you have any confusion, it may get clear. So as per your question, what are the parameters as given? First, electron mobility is given, that is 0.38 meters per Vs. Then the temperature is given 300 Kelvin. Voltage, constant voltage is given, that is voltage main constant. Charge is also given, right? All these parameters are given in your question itself. So you can calculate the thermal voltage. So you can also remember thermal voltage, the standard value of the thermal voltage is 25 millivolt, right? So if you will put the values kT by Q from these, the K and T and Q, then you will get almost 25.85 millivolt. So standard you can use 25, right? Okay, so once you will get the thermal voltage, then formula is very simple. D is equal to mu into Vt. Vt is nothing, Vt means Kt by Q, right? So here now if you will put the value of mu and Vt, you will get the 98.23. So your correct answer is 98. Clear? Okay, let's go for another question. So another question is, an electric field of 0.01 volt per meter is applied along the length of a copper wire of circular cross section with diameter 1 mm, right? So here what is that? Here like some electric field has applied across some copper wire, right, having diameter 1 mm. So in the previous question, we have found the diffusion current, right, diffusion constant due to the concentration gradient. In this question, what is that? In this question, question is already it has given the electric field. So here the current will flow due to the drift current. So there are two different types of the the source of the current. So first one is your diffusion, that is concentration gradient, and drift, that is the that is voltage application, right, external voltage. So copper has a conductivity is given. Now you have to find the current, right? Current means drift current, right? As per answer key, your answer should be 0.46, right? Yeah. So drift current, how can we find out? So drift current can be found using this formula, that is J is equal to NQVD, right? VD is equal to mu into E, drift voltage. This is, so VT is equal to mu into E. So finally J will be equal to NQ mu E, that is conductivity into electric field. Conductivity means your N, Q, mu. So conductivity is mu and E, right? Mu and E. So mu is your mobility, N is your concentration, the numbers, and then Q is your electronic charge, that is E, that is 1.6 into 10 to the power minus 19. Right? So this is our target. So our target is to find the current. This is a current density. So once we'll get the current, then we'll multiply with the area, right? Then we'll get the final amount of the current. So now let's dive into the drift current. How can we find out? So here is a question. So what is the question? Question is given electric field of 0.01 voltmeter has applied. Suppose this is a copper wire and now electric field is applied. Why electric field is applied? Due to the some external voltage. What is the value of electric field? 0.01. It has already given diameter. So diameter means the cross-sectional area. You can easily find why area is equal to pi r square, since this is your circular, right? So area of the circle is pi r square. So r will be how much? Diameter by 2. You can find out the area. Once we'll get the area, and then once if we'll find out the j, that is mu and e, and then we can easily find out the current. So this is a technique. Finally you will get the current, that is 0.46, right? So in this question, what are the quantities has given? Your conductivity has already been given, means J is equal to your conductivity into electric field, and electric field has also given, right? So nothing to do, just find out that current density, conductivity into E, and then after getting the value of current density, we can multiply the area, we'll get the final current. Clear? Okay, let's go for calculation. So your answer is, correct answer is A. Okay, so calculations. So electric field is given, diameter is given, and the conductivity is also given, right? If in some question, instead of the conductivity, they might be give you the values of mu and E, right? Mu means your mobility and mobility of electron and hole both, of course, and then N, that is your concentration and electronic charges, and then they will ask to find out the same your current, right? So in that case, you have to find out the conductivity, but here it has already been given, so no need to find. So first find out area. Area is equal to pi r square, you will get this value, and then the current density. Current density, that is J is equal to your conductivity into electric field. So you can get the value here after putting the values of conductivity and electric field, and then after you can multiply the J into A, and you will get the total current. So finally you will get the total current of 0.46 ampere. So that's all in this session. We'll take some more question in another sessions. Thank you to join the session. If you have any problem, you may drop your comment.